This is a word problem on dimension. We are going to use the dimension to find the relationship between period, mass, length, and acceleration due to gravity. Now, here is the question. A small mass is suspended from a long thread so as to form a simple pendulum. The period t of the oscillation depends on the mass m, the length L of the thread, and acceleration g of free fall at the place concerned. Now we're given that period is equal to k m raised to power x, l raised to power y, and g raised to power z, where x, y, z are unknown and k is equal to 2 pi. Now we are to find the value of x, y, z and also derive an expression which is also formula relating t, m, l, and g. Majorly, this is what dimension is used for. You use to derive formulas and expression. Now, how do we go about it? Let's start from the question. Period t depends, which means it's directly proportional to mass m, length l, and g, acceleration. Now t is directly proportional to mlg. Now when you remove the proportionality sign, this is the proportionality sign, when you remove it, you have your t equals to k, m, l, and g, of which they carry a particular index of what? Of x, y, and z. These are unknown. We don't still know how the formula is going to be formed. Using dimension analysis, we have our t is equal to k m raised to power x, l raised to power y, and g raised to power z. Now, at an ideal condition, our k is equal to 1. Then we have t is equal to m raised to power x, l raised to power y, and g raised to power z, where t is the period, m is the mass, l is the length, and g is the acceleration due to gravity. Now from here, we all know our parameters. Now I'm taking time to explain this so we'll get the understanding gradually how you can use dimension analysis or dimension to find the formula of quantity in a word problem. Now, what is the dimension of period? Period is the time taken for a complete circle. It's measured in seconds, which means that's time taken. Now, dimension of period is also t. Dimension of m is mass. That will be equal to capital letter M. The dimension of length, L, that's L. Now, here is acceleration. The dimension of acceleration will be calculated because it's not among the fundamental quantity, it's a derived quantity. Now, how do we go about it? Dimension of acceleration. Now, firstly, what is the formula for acceleration? Velocity over time. And resolving this into a simpler form, you have velocity to be displacement over time. Then you have displacement over time divided by time. Now, what is the dimension of displacement? Take fundamental quantity of length, is measured in meter. That is, the dimension of displacement here will be L. The dimension of time is t, and the dimension of time is t. Then you have the dimension of acceleration to be L over t square, which is L t raised to power minus 2. Having gotten all the dimensions of all our parameters, period, mass, length, and acceleration due to gravity, we substitute those dimensions into the equation given. This equation, that is t is equal to m raised to power x, l raised to power y, g raised to power z. Now, this is at ideal condition. Now, let's begin to substitute. Period. What is the dimension of period? The dimension of period is t. Then you come back to your equation. The dimension of period is t is equal to, the dimension of mass is m. Then you have capital letter M raised to power x. Now, what is the dimension of L? This L, the dimension of L is capital letter L. You have it to be L raised to power y. Now the last one, the dimension of acceleration due to gravity is Lt⁻², then you slot it in Lt⁻²z. Now, having gotten this, we can also have dimension of m⁻⁴, dimension of l⁻⁴, dimension of t, which is equal to dimension of m⁻⁴x, dimension of l⁻⁴y, dimension of lt⁻² or ⁻z. Now, why do we have to express this? So that you can compare the left hand side and the right hand side. Now, m⁻⁴ is what? 1. l⁻⁴ is 1, and we have our t still back here. Now, m⁻⁴x, this is it, l⁻⁴y, this is it, and lt⁻²z, this is it. Now, let's express everything. Now, you have your m⁻⁴ times l⁻⁴ times t⁻1 is equal to m⁻x times l⁻y. Now, once you open this bracket, you have times l⁻z times t. This is -2 times z⁻²z. I believe you're following me. Now, compare the right hand side. Compare the right hand side and the left hand side. Now, here we have our value of x to be 0, y to be 1/2, and z to be -1/2. Now, if you look at our question, it says find the value of xyz. Now, we've gotten our value of xyz. Now, the second question says hence derive an expression relating t, m, l, and g. Here we come back to our equation. T is equal to m⁻x, l⁻y, and g⁻z. Now, let's bring it out. You have t is equal to k m⁻x, l⁻y, and g⁻z. Now, here we slot in our value that we got to get this expression. Then our t is equal to k m⁻⁴, l⁻⁴ and g⁻⁻⁻⁴. Here, let's continue. We have t to be k, m⁻⁴ is 1, l⁻⁴ is square root of l, and g⁻⁻⁻⁴ is times 1/√g. Now, recall, k is equal to what? 2 pi. K is giving us 2 pi. Now, let's slot it in. We have the expression to be t is equal to 2 pi times √l/√g, which will give us 2 pi square root of l/g. Now, this is the expression we are meant to look for. Now, the expression for period is what? Is 2 pi square root of l/g, which means the calculation is not dependent on mass. It's not dependent because mass out of this equation was ruled out. Now, if you check the video again, look over it again, you'll be able to understand how you can find an expression or a formula using dimension analysis. Thank you.